Here we are at Lesson 12. I'd like to take a moment to look at where we've been, what we're doing now, and say a few things about where we're going. In the first 5 lessons, I tried to give you an overview, just a broad general idea of what AFM is and does and why. Then lessons 6 through 11, we talked exclusively about constant force contact mode of AFM. That's the easiest one to learn, and I tried to give you some main ideas of what's important when you sit down and try and acquire some images. I hope you found an AFM to practice on, and while you're practicing, let's step back for a moment, away from the lab, if you will, and talk about related instruments and related data acquisition modes on the AFM. Coming up, we'll return to the lab, so to speak, and talk about calibration of AFM. And then later on in the course, we'll talk about the interpretation of the data. Now, related instruments. AFM is one of a whole large family of instruments called scanning probe microscopes. And in this family there might be 50 or so different variations. It's rather hard to keep track of everything. It's rather much like an alphabet soup because each variation has its own acronym. There's no time in any one course to tell you about all of them. Turns out AFM is the most popular for many of the reasons I mentioned in Lesson 5. It works in many environments. It works on a lot of different types of samples. It's not too expensive, etc., etc. So one microscope, probe microscope that I will mention is scanning tunneling microscopy. And one variant of AFM that I'll mention is lateral force microscopy. I'll be doing lessons on each of these. And there are lots of different data acquisition modes of atomic force microscopy itself. So I'll save those names for later. 3 additional acronyms today is probably enough. For SPM in general, how would one think about the instrumentation? That's what we'll do next. You might remember this slide from Lesson 4. It's constant height mode in AFM. Height of the scanner remains the same. It rasters back and forth in X and Y, and you record the deflection of the cantilever as a function of X and Y position of the scanner. All we have to do to change this to a generic scanning probe microscope is take out the scanner, photodiode, and cantilever. Now we replace it still with a scanner. After all, it's scanning probe microscopy. Here's the scanner, here's the probe. It's a sharp tip, and there's some kind of interaction between the probe and the sample. That interaction could be anything that you can measure: ion current, magnetic forces, whatever, something you might think of in the future. So the key is that we have some means of detecting that interaction strength as you scan back and forth in X and Y. The image, it's still a constant height image because the scanner is still at the same height. It will be the strength of that interaction as a function of X and Y. Here's another slide from Lesson 4. This is constant force mode in AFM. And to turn this into a sketch of a generic scanning probe microscope, all we need to do is again, take out the scanner, photodiode, and cantilever, put the sketch of the scanner back in, have a sharp probe that's in proximity to the sample surface, have some kind of interaction. You're measuring optical, let's say, and let's say the scanner is driven by the electronics, but now we have a feedback loop that's looking at that strength of that interaction and trying to keep that interaction constant, moving the scanner up and down in Z as it's being rastered back and forth in X and Y. So you could call this the constant interaction strength mode, which is a very long name. But in AFM, of course, it's constant force mode, because that's the thing that we're keeping constant. In summary, what we did in this short lesson was to talk about the operating principles of the family of instruments called scanning probe microscopy, of which atomic force microscopy is the main focus of this set of lessons.